Atom history. Atom is the smallest particle of an element that retains its identity in a chemical reaction. There are three subatomic particles: protons, neutrons, and electrons. Protons and neutrons are located in the center of the atom called the nucleus. Electrons are the smallest subatomic particles and move constantly around the nucleus. Let's see its history. The first person to talk about the atom was Democritus in 460 BC to 370 BC. Democritus was a Greek philosopher, among the first to suggest the existence of the atom. According to Democritus, if you cut something again and again, you will get to a point where you can't cut it anymore. And this particle is called atomus in Latin, meaning indivisible. The atom model, according to Democritus, will be a round sphere. After him, it passed a long time until John Dalton in 1766 to 1844, he proposed a new theory. He was an English teacher of math and natural philosophy. What he proposed was greatly influenced by Newton. Dalton's atomic theory is divided in 4 points. The first one states all elements are composed by tiny indivisible particles called atoms. Second, atoms of the same element are identical and are totally different from another element atoms. Third, atoms combine in fixed proportions to form compounds. And fourth, chemical reactions occur when atoms are separated, joined, or rearranged. Like again, John Dalton believed that the model of the atom was a sphere, circular sphere. After him came J.J. Thomson, 1856 to 1940. He was an English physicist, and he discovered the electrons, which are negatively charged subatomic particles, and he believed that they were immersed in a big positive mass. For this, he used the cathode ray experiment. In here, electricity passes from an anode to a cathode, which are inside of a tube filled with a gas and sealed, forming a glowing beam. Then the magnet is approached, making the beam to deflect and prove the electrons are negatively charged. According to J.J. Thomson, his model is called the Plum-Puttill atom model, where there will be a huge positive mass and the negative electrons will be immersed in it. After him, we have Robert M. Millikan, 1868 to 1953. He was a U.S. physicist, and in 1916 he discovered the quantity of a charge carried by an electron equal to be a 1 unit, and its mass to be only 1 over 1,840, the mass of an hydrogen atom. For this, he used the oil drop experiment. In this experiment, all droplets are sprayed into a sealed chamber in which the inner plates are charged. Electrons stick to the droplets, making them shine like little stars. And because of gravity, these droplets tend to fall, making it possible to determine their mass. Like again, the model that he believed in, it was the Plum-Puttill model. Then Eugen Goldstein, 1850 to 1930. He was a German physicist, and in 1886 he discovered the protons as the positively charged particles, which has a mass of 1,840 times the mass of an electron. In the way that he discovered the protons was exactly using the cathode ray tube that J.J. Thomson used. And he found out that some rays will bounce to the opposite side. He called them canal rays at the beginning, and later on, when he determined that they were positively charged, he changed the name to protons. Ernest Rutherford, 1850 to 1930, he was a New Zealand-born British physicist. and in 1911 he discovered the nucleus of the atom, locating it in the center of it. For this he used the gold foil experiment. In here he used alpha particles, there are helium particles, that were fired against the gold foil, expecting all of them to pass through it. But some of them bounced back, and this indicated that the atom was almost empty space, and in the center was all positive particles. In this moment, the model of the atom looked as center, that it would be the nucleus, all of it positive, and the electrons spinning around. Then Niels Bohr, 1885-1962, he was a Danish physicist. In 1913, proposed that the electrons move in circular orbits at fixed distances around the nucleus. This model was called also the solar system model. In here, the orbits around the nucleus are called shells, and each shell have different energy levels. An electron can move from one level to the next, and the energy required for it is called quantum. After him, Sir James Chadwick, 1891 to 1974. He was an English physicist, and in 1932 he discovered that the neutron, a particle with no charge, located in the nucleus together with the protons and with the same mass. For this, he used the beryllium foil experiment. This experiment was very similar to Rutherford's, but Chadwick used beryllium instead of gold, and instead of helium or alpha particles, he used polonium, allowing him to prove the existence of neutrons. By then, the model of the atom looked at a nucleus with protons and neutrons and electrons spinning around in fixed orbits. Then we have Erwin Schrödinger, 1887 to 1961, and Werner Heisenberg, 1901-1976. Schrödinger, an Austrian chemist, in 1921 he proposed the existence of electron waves in an atom and allowed us to find the probability of an electron's position. In short words, he said that the electrons move in waves. In the other side, Heisenberg, a German physicist, in 1927 he proposed the uncertainty principle, that states that when you are trying to locate an electron by striking it with light, you can see where the electron was, but not where it is, because it gets excited with the energy of light and jumps to another location or energy level. Putting these together, both of these ones created what we call today the quantum mechanical model. Thank you for watching this video.